Okay boys, so now we're going to be going through some examples on this work. So in this question here it says classify each triangle according to its sides and angles. So we're going to have an answer for looking at the sides and another answer for looking at the angles. So if you look at this first one here, looking at its sides, we can see it's got 3 different side lengths there. So that will be scalene. And looking at its angles, well, they haven't given you any degrees, so we're going by the look of them if they don't give you any degrees. This looks acute, that one looks acute, but this one here looks obtuse. So that one's an obtuse angled triangle. Okay, over here in B, we've got 3 equal sides, so it's an equilateral triangle. And if we look at the angles, that looks acute, that looks acute, and that looks acute. So it's an acute angled triangle. But remember, you also knew already that because it's equilateral, that all of those angles are going to be 60 degrees each. So that has to be acute angled, because you know 60 degrees is an acute angle. Okay, in C, looking at the sides, it's got 2 markings of equal sides. So we're going to say it's an isosceles triangle for the 2 equal sides. And it's pretty obvious you've got an angle there that's a right angle, so the triangle is right angled. Okay, so in question 2, they're asking you to sketch a triangle that's right angled and scalene. So first of all, we'll draw the triangle that's right angled. And then have a look at what they've said there. Scalene has to have all the sides different. So just make sure they're all different. So you can either mark them with different side length markings like that, or you could write side lengths on there. So you could say, well, this one's 3 centimetres, this one's 4 centimetres, and this one's 5 centimetres. Okay, in question 3, what type of triangle is this? You've 2 answers. Okay, so it's another way of saying classify the triangle. They haven't said by looking at the sides and by looking at the angles, but they're the 2 answers you're going to be giving. Okay, so the first one, if we look at the sides, we haven't got a lot of information here, but if you look at the angles, it'll help you get some information about the sides. So this is 35 degrees, and if that's an equal angle, the opposite side to that and the opposite side to that must be equal. So just get your red pen and do that. If you've got 2 equal angles, go opposite the 2 equal angles and you'll be pointing at 2 equal sides. So mark them as equal with your red pen, because that's you working that out. They didn't tell you. And then you can say, I can now see we've got 2 equal sides, so it's an isosceles triangle. We might just write 2 equal sides underneath so you can see where we were getting it from. Okay, and the next one, we're looking at the angles. Now, we can see that's 35 degrees, that's an acute angle. This one's 35 degrees, this is an acute angle. But we don't really know what that is, so we can't comment yet. So we're going to find that other angle. So I'm going to start with that 180 degrees for our triangle. Take off the 35 and the other 35. And use your calculator to work that out. And it gives you 110 degrees. So looking at my triangle that's not drawn to scale, that looked like it was probably an acute angle. But when we worked it out, it's not an acute angle at all. Hasn't been drawn to scale. And often they will say not to scale or don't look at the diagrams. It's 110 degrees. That's an obtuse angle. So this actually worked out to be an obtuse angled triangle. So these are the sort of questions that they can put in exams to try and sort out the boys that really know what they're doing from the people who don't. All right, these other questions here, they're the ones that we expect people to be getting them right. But once we get to something like this, we're really trying to see if you can work things out a little bit better. All right, now number 4. Is it possible to draw an obtuse angled equilateral triangle and justify your answer? Okay, so two things they're looking at. Obtuse angled and equilateral. Well, if you know enough about equilateral triangles, you should know the answer to this. Right, because back over here we were looking at an equilateral triangle. We can see it have all three equal sides, but it's what's going on with the angles that we're more important here. And we know that they're 60 degrees. Each angle in an equilateral triangle is 60 degrees. Can't possibly be obtuse. Okay, we can't have an obtuse angle in a triangle that's equilateral. So to justify this, we're going to write this down. All angles in an equilateral triangle are 60 degrees each. Therefore, the triangle would have to be acute angled. Because all of them are 60 degrees. So therefore, no, not possible. You don't always have to answer the question first and then justify it. Sometimes it's better to justify what you're talking about first and then say, yep, not possible at the end. Okay, in example 1. So we're going back to the triangles over here in example 1, these three. And we want to know which triangles have, firstly, line symmetry, and then secondly, rotational symmetry. So if we look back over here at A, this has three sides that are not equal. Okay, so there's nothing that we can draw in here to be an axis of symmetry. It doesn't matter where you would draw it. These lines are all different lengths, so that's not going to have line symmetry. Alright, so A is got no, A in this one here does not have line symmetry. I might just change this to be part 1 so we don't get confused with the A's and B's. Alright, the next one, let's see if that has line symmetry. Well, that's an equilateral triangle, so there should be something symmetrical going on there. So in B, if we have a look at this equilateral triangle, it will have line symmetry. Okay, I can draw straight through here to be an axis of symmetry from this corner to the middle of that side. I split that into two equal bits. Okay, and then I'm going to do that for all of those points. So I'm going from this corner to the middle of the opposite side, and from this corner to the middle of the opposite side. So I've drawn in three axes of symmetry. So yes, it definitely does have line symmetry. Okay? The next one. C, this one here. So it's right angled and isosceles. So if we draw that, I haven't drawn it very well, but just pretend those sides look a bit more equal than they do. We do have an axis of symmetry here. If we go from here and go straight between the two equal sides to the middle of the opposite side, so these two bits are the same, that's an axis of symmetry. It's not going to have any more than that. It's just going to have, so just turn this around. It's only going to have that one axis of symmetry. Okay, because we don't know what this third side length is, and you can't really split between something you don't know and that one. Alright, so that will be the only one. You can try it yourself, draw one, cut it out, and that will be the only place you can fold it, where it works. Alright, in part 2, we're looking at rotational symmetry. So remember that's when you put a centre point, and we're going to spin the shape around and see if it falls on top of itself. That's not going to work for rotational symmetry. We've got three different side lengths. Nothing's going to fall on top of itself there. I hope you can see that. In B though, it will. Okay, we have an equilateral triangle. If I put the centre point in the middle here and I start to spin it, when I start spinning it, this point here will spin and move to there, and the shape will be right on top of itself. Then if we continue to spin, it'll land in that spot. Continue to spin and it'll land back to where it started. Okay? So actually, if you wanted to work out how many degrees you were rotating around, it's 360 degrees for the full spin. Divide by 3, and you're actually spinning 120 degrees each time. You don't really need to know that, but it's just helpful to see what's going on. So if you spin 120 degrees, it'll land on top of itself. Another 120 degrees, it lands on top of itself. Another 120 degrees, and it lands back on top of itself at the beginning. So we do have rotational symmetry there, and it's order 3. Because it lands on top of itself 3 times. Okay, let's have a look over here at this one. That's our last one. So we've got to think about this one carefully. So we've got 2 equal sides. When we spin it, will it look right? Well, let's have a think. If we spin it, start from here, spin it. It's not looking like itself yet. It's got to fall on top of itself, remember? If you continue to spin it, it'll be down here, upside down. So even though it looks like it's got rotational symmetry, this one's not going to have it, right? So it's not actually going to have any rotational symmetry. If you cut out a triangle that's got 2 equal sides with a right angle and then try to spin it yourself, you'll find it doesn't actually ever look like that again. So that's the only one with rotational symmetry. We're going to come back in one more video because I have to do a few more reasons in geometry with you.